Dear viewers, welcome to my YouTube channel Electrical Passionate. Subject of discussion of this day is overcurrent relay and protection. The following subject will be discussed like general protection scheme of a line, working principle of an overcurrent relay, about overcurrent relay, classifications of inverse time relay characteristics curve, directional overcurrent relay, and different types of overcurrent protection scheme. The video will be a little lengthy, so request you to watch the video till the end, and if you like, do everything in my favor. Please watch now. This is a general protection scheme of an electrical line is being shown here. Power enters into the circuit breaker through incoming lines and delivered through outgoing lines when circuit breaker closes its contacts. Fixed and moving contacts remain inside an insulator petticoat. At each outgoing line, an instrument transformer is installed named current transformer CT in short, in series to measure the current flowing through the circuit and for protection and control of the said line. When by any chance, either by fault or overload, CT current exceeds the rating and setting also, the CT send a signal about it to the relay. Relay instantly measures this excess current and it sends a tripping command to circuit breaker. Circuit breaker trips instantly by departing its inside contact and protect overall system from damages. This is the general process of a protection scheme. Circuit breaker makes or breaks a circuit during normal and abnormal condition. Current transformer CT steps down current for measurement, protection and control. Relays are electrically operated switches that open or close a circuit by receiving electrical signal from outside source like CT when current in the CT coil exceeds the presetting value. What is fault? A fault in an electrical system is defined as a defect in its electrical circuit or equipment due to which the flow of current is diverted from the intended path, results high current to flow through the equipment. Why fault current is high enough? As the fault impedance is less than load impedance, the fault current is more than load current. If a short circuit occurs, the electrical impedance is reduced to a low value and therefore fault current is too high. Overcurrent relays sense fault current and also overload currents. In an electrical system, and overcurrent relay is a protective device that detects abnormally high current due to fault like short circuits or overloads and then issue a trip to circuit breaker to isolate faulty sections. It works by using a current coil connected with a CT to monitor the system current. When normal current flows through the coil, the magnetic effect generated by the coil is not sufficient to move the contacts of the relay, as in this condition the restraining force is greater than deflecting torque. But when the current through the coil increased, the magnetic effect is increases, and after certain level of current, the deflecting force generated by the magnetic effect of the coil crosses the restraining force. As a result, the moving element starts moving to the contact position of the relay. A relay that operates or picks up when its current exceeds a predetermined value, preset value, is called overcurrent relay. Overcurrent relay protects electrical power systems against excessive currents due to short circuit or overload. Use of overcurrent relay is to protect feeder, transformer, alternator or generator, motor, etc. Overcurrent relay gives protection against short circuit due to phase fault, earth fault, winding fault. Primary requirement of overcurrent relay for protection of a system. Protection should not operate for starting current, permissible overcurrent, current surges. To achieve this, relays are incorporated with time delay. The protection should be coordinate with neighboring overcurrent protection. Overcurrent relay is a basic element of overcurrent protection. The basic element in overcurrent protection is an overcurrent relay. Depending upon the time of operation, overcurrent relaying has following types: high speed or instantaneous overcurrent relay, definite current, definite time overcurrent relay, inverse definite minimum time overcurrent relay, idmt, A inverse, B very inverse, C extremely inverse. Directional overcurrent relay. Instantaneous overcurrent protection. The relay trips a circuit breaker with no intentional time delay when current exceeds a preset pickup value, providing rapid protection against short circuits. This simplest form of overcurrent protection operates in a matter of milliseconds due to inherent delays, but offers fast clearance to limit equipment damage. Operating time is constant and operates in 0.1 second or less. Application used for outgoing feeder. Definite time overcurrent relay. The relay trips opens a circuit breaker after a fixed predetermined time delay. Once the measured current exceeds a set or pickup value, Unlike inverse time relays, its operating time is independent of the magnitude of the overcurrent. Operating time of definite time overcurrent relay is constant. Operation of definite time overcurrent relay is independent of magnitude of current above pickup value. It has pickup and time dial settings. Desired time delay can be set. Tripping time is independent of fault current and fault location. Applications used as backup protection. Inverse definite minimum time overcurrent relay IDMT. The characteristics with definite minimum time and of inverse type is also called inverse definite minimum time IDMT. An inverse curve is one in which the operating time becomes less as the magnitude of the actuating current quantity is increased. However, for a higher operating current, actuating current, the time is constant. Definite time curve is one in which operating time affected by magnitude of actuating current. However, even definite time relay has a characteristics which is slightly inverse. In definite characteristic, the time of operation is almost definite. That is, I to the power 0 into t equal to k. That is t equal to k. In inverse curve characteristics, the time of operation is always inversely proportional to current, that is I to the power 1 into t equal to k, that is I equal to k by t. In more inverse characteristics, I to the power n into t equal to k, n may be between 2 to 8. Directional overcurrent relay. Overcurrent protection can be given directional feature by adding directional element in the protection system. Directional overcurrent protection responds to overcurrents for a particular direction of flow. If the power flow in the reverse direction, the directional overcurrent protection remains inoperative. Under healthy system conditions or under faulty conditions, where the current flow is in normal direction and along the direction of tripping of relay, the directional overcurrent relay will issue a tripping when current exceeded the set value. If flow of current is in opposite direction of tripping, then the relay will remain inoperative. The directional overcurrent relays are used when power can flow from both directions to the fault point. For phase-to-phase fault, that is overcurrent fault, only affected phases relay will operate. For earth to phase fault, only affected phase relay would operate. But for overcurrent relaying, setting is kept too high and the desired sensitivity with earth fault cannot be obtained. For phase-to-phase faults, the relay of affected phase will operate. Under normal condition and three-phase fault condition, the current in the three phases are equal and vector sum of all current is 0. No current will flow through the earth fault relay. When this balance is disturbed, current will flow through the earth fault relay. For phase-to-phase fault, at least one overcurrent relay will operate. For earth fault at any phase, earth fault relay will operate. Thank you for watching this video.